Welcome. Today we're going to be taking a look at the notes worksheet entitled Bearings. And this lesson offers us an opportunity to do some good applications with right triangle trigonometry. It should be noted, by the way, that we will come back to the concept of bearings later on this semester when we do non-right triangle trigonometry. But for right now, all the problems we do will form, conveniently enough, some nice right triangles. And so we definitely have the foundation to be quite successful with this. So let me go ahead and read what I have on your paper here, and then we'll go for it. It says bearings are used to describe the location of one point relative to another. So not distance, but it's location, one point relative to another. And it looks like I just have an example here. Boulder High School is located at a bearing of, and as a matter of fact, I sat on my porch with my GPS and took a bearing from where I was sitting to the coordinates of Boulder High School. And this is actually, we'll kind of talk about this as we go through the process, but this is how it worked out. From the north axis, rotated 88 degrees in a westerly direction. And so that would be the bearing, and I'll give you a little quick diagram to kind of show you what that would look like. Basically, just off to the side here, I'm going to put a little north-south line as we will be drawing in with all these problems. There's my front porch right there. And very simply, a certain number of miles away, Boulder High School is about here, give or take, maybe a touch lower. But essentially, this is a way to describe Boulder High School's location in relation to my house's location. And so what this basically means is we're going to rotate off that north axis right here, 88 degrees in a westerly direction. And if you can envision maybe a terminal side going from my house to Boulder High School, right in here, guys. I'm going to try to get that in as nice as possible for you. That would be the 88 degrees. So again, it's a way to describe the location of one point relative to another point. And let's go ahead and take a look at this piece. It says angles used in the description of a bearing. And if you can underline this for me, even though I bolded it on your paper, acute angles, so always in between 0 and 90 degrees, and always rotated from the north-south axis, as I kind of showed you when I drew my little diagram up there. And obviously we'll just kind of get some practice with that idea. Go ahead and draw some things. I'll give you some bearings. You give me some sketches. I'll give you some sketches. You give me some bearings, and so forth. Okay, good. Well, let's kind of move forward with this. I have an example one there that will kind of get us thinking in the right direction. A couple, really 4 different ideas here. So let's go ahead and read and see what it says. Draw 4, quote, coordinate planes and label the 4 directions, north, south, east, and west, and then label each origin just O. Okay, so I think I left a little room on your notes worksheet here to kind of pull this off. And so if you get an opportunity, everybody, give me 4 kind of side by side like this would do. So north, south, east, and west. And if you get an opportunity, I'm going to go ahead and do that. North, south, east, and west. And then what we're going to do is kind of start right there, and we're going to call that point O if you get an opportunity to do that as well. So let's repeat the process in all 4, please. North, south, east, and west. And we'll kind of start there with our initial point right at the origin, so to speak. Okay, 2 more for me. And then last one over here. And then we'll do the 4 kind of different scenarios that we'll see. So got that. Okay, perfect. And so it looks like the way we'll play this out, everybody, is A, B, C, and D. Kind of talk about how we're going to write it, how we're going to say it, and then again, sort of the 4 different, quote, quadrants here that we'll see our secondary point. So let's see what it says for part A. Lightly draw an initial side of an angle on the north axis. Okay, so everything is going to either rotate off the north or south axis. So just kind of starting out here. Here's my initial side going from here to here. And then it says rotate 35 degrees clockwise and draw a terminal side. So we're going to rotate clockwise. That would be this way, 35 degrees. And we'll just go ahead and ballpark this. And so maybe something like this. And label a point on the terminal side A. So I'll just go ahead and put that right up here. And what we want to do is have a description of one location to another from point O to point A. And the way we're going to do that is with that bearing. And so it says the bearing from O to A is denoted as, And so let's kind of be clear about a couple things here. And by the way, I forgot to label this, so let me go ahead and do exactly that piece. There's your 35 degrees right in there. Okay, perfect. So I have it as where you start. So everyone, we rotated off the north axis here. Then we went 35 degrees. So my terminal side rotated 35 degrees in an easterly direction. So I hope everyone's okay with that piece. When I talked about that clockwise, we went in an easterly direction. And so those are going to be the three components to our bearing. The initial side, which axis we're rotating off of, describing the rotation, and in which direction did the terminal side rotate. The way we would read this, by the way, and I'm just going to sort of put this with quotations, but basically we would say this is 35 degrees east of north. And that's how you'll hear me say this over the course of going through this lesson. 35 degrees east of north. Okay, that's exactly it. That would be the first bearing, from here to here. Okay, let's do letter B. Lightly draw an initial side on the north axis. Let's do that again, everyone. So I'm going to rotate off the north. Rotate 70 degrees counterclockwise and draw a terminal side. So now we're going to start here, everyone. I'm going to go 70 degrees. Again, notice the description or the angle of the bearing, acute angle. And so about 70 degrees and then a terminal side. And just go ahead and find a point there and label that B if you would. And so this was 70 degrees in here. Starting on the north axis, rotated 70 degrees, and we did this in a westerly direction. And so it says on your paper, the bearing from O to B is denoted as, here's where we started, here was the rotation itself, and then here was the direction that the terminal side rotated. North, 70 degrees west is just how I'm looking at it, but we would read this in a slightly different manner. We would say this as 70 degrees west of north. Okay, good. So 2 down, and just 2 other scenarios to take care of. Letter C, everybody. Lightly draw an initial side on the south axis. Okay, so here, everyone, we're going to start it out on the south axis. Rotate 40 degrees counterclockwise. So this will be going this direction, 40 degrees. Again, from here to the east axis would be 90, so 40 degrees, maybe something in there. Put a terminal side and label that C. And so as a result, everybody, that would be 40 degrees right there. And so what I want to do is describe the bearing from O to C. And now I think we've got a little rhythm with this. So the bearing from O to C is denoted as off the south axis here. That's where we want to be careful. Off the south axis. And I rotated 40 degrees. And it looks like I went in an easterly direction. And so we would read this, of course, just kind of put in quotes there, 40 degrees east of south. Wonderful. Well, you can probably figure out at least where the last one will be, but let's go ahead and take a look at D. It says lightly draw an initial side on the south axis. So last time around, everybody, let's go ahead and pull this off. So there's my south axis right there. I'm going to rotate 80 degrees clockwise. So that's going to be this way up here. If I went 90 degrees, I'd hit the west axis. So 80 degrees, and make yourself a nice terminal side. Point D out here. So we want to describe the bearing from O to D. And it's all based on rotating off that south axis 80 degrees in a westerly direction to get from O to D. And so as a result, everybody, it looks like, again, where you start, so south, describe the rotation, and then describe the direction of that rotation. So south, and then 80 degrees, and then a west. And again, we would read this as 80 degrees west of south. Okay, so those are going to be the 4. The key, what you're just going to have to get used to, is it's not an angle in standard position where you're starting here and you're rotating here positive or here negative, counterclockwise and clockwise. It's literally just starting out at different initial sides, either off the north axis or the south axis. And then from there, again, the bearing is also always described as an acute angle between 0 and 90 degrees, of course. All right, good. We'd love for you to actually try this one on your own. That would be the ideal. It says use the figure to determine each of the bearings from point O. So take a moment. It looks like I just pasted a quick diagram in there. And so I guess something along these lines right here. How about we all write this together and then let you pause the video for a second, give it a try. So O to A, O to B, O to C, and then O to D. So it'd be great if you can pause the video and then come on back and then see how you did. See if you went 4 for 4. Okay, well let's take a look. So here is the bearing from O to A right out here. This one right away, everybody, we do have to be a little careful. I know it kind of gave us this standard position angle right here as a theta being 20 degrees, but the bearing, remember, of course, is always from the north or the south. So theoretically, everybody, I want my angle measure when I describe the bearing as rotating from here to here. So I'm hoping you all realized we're starting on the north axis, and I would be rotating 70 degrees in order to get from there to there in an easterly direction. So my bearing in this particular case was starting on the north, 70 degrees. That's the key, even though that little diagram tried to trick us and gave us 20. So the angle is 70 degrees and then east. And so that would be 70 degrees east of that north axis. Okay, O to B. So from here to here, again, it looks like I'm rotating off the north and given directly as there's the angle right in there. It looks like I have north, 40 degrees, and a west. Okay, letter C. So from O to C, describing that location. And it looks like in this case, I do have to be careful again. It looks like I want to either rotate north or south, and here definitely south. From here to here, I'd rotate from here to here, and so I'm seeing it as a south rotation, or I should say a south initial side, a rotation of 15 degrees, and again in a westerly direction there. So south, 15 degrees, and west. Okay. This angle right there is not part of the bearing. From the south to the terminal side, that's the bearing. And then that last one, let me see if I can catch that. It looks like from O to D, again off the south axis, it looks like we're rotating directly 25 degrees there, and I'm going in my easterly direction. And those are your 4. Okay, great. Initial side, angle, which direction did that terminal side go? It looks like I threw a little note on your paper here, so I'll do a quick read through, and then we'll go ahead and hit the 2 applications just on the back side. So it says, there is a second way to calculate a bearing that is referred to as an azimuth. This would entail calculating an angle that's rotated clockwise from the north axis and can be measured anywhere from 0 to 360 degrees. However, we will, of course, be using the measurement of the bearings as described at the top of the page. So my understanding is this azimuth right here, this description of a bearing, is used primarily in navigation, so air navigation, marine navigation, land navigation, and so forth. But surveying techniques use the bearings described like this up here with the acute angles. So just a quick description on what an azimuth is, and then we'll kind of roll. Basically, you start at the north axis, everybody, and you would rotate clockwise from there. So, for example, if I have a point from here to here, we wouldn't talk about a north-south axis or something like that. It would basically just be rotating off the north axis clockwise from there to there. That would be your bearing. And it's always a positive value in between 0 and 360 degrees. So as I said, we're going to be using this description up here, but there is another way to represent a bearing, just using, instead of a north and south axis and an east and west, it's just a number. And so that would be the case, rotating clockwise off the north axis around. All right, well, let's go ahead and try our 2 applications here, everybody. So as I said, these 2 problems here are very convenient, let's put it that way, in that we're going to see nice right triangles, and so we can kind of fall back on our experience with right triangle trigonometry with this stuff. So let me read through it, and let's see if we can draw some things out and get an understanding of it. A boat leaves the entrance to a harbor and travels 25 miles on a bearing of 42 degrees east of north. The captain then turns the boat 90 degrees clockwise, again, convenient enough, and travels 18 miles on a bearing of 48 degrees east of south. At that time, how far is the boat from the harbor entrance? And also, of course, what is the bearing of the boat from the harbor entrance? Okay, well, the best thing to do, and I think I will draw this with you certainly the first time around, and in the last example, example 4, I will ask you to go ahead and try to draw the figure on your own and see if it works out and see if you get what I get as a result. Okay, well, let's try this out here, everyone. So somewhere, leave some space, but I'm going to go about right here, and let's see, I'm just kind of thinking about this. I'm going to go ahead and draw a north-south line with my point right there. So everybody, there's the harbor. And it says we're going to go 25 miles on a bearing of 42 degrees east of north. So everybody, we're going to rotate off the north axis, 42 degrees, and follow that bearing for 25 miles. So what that means, everyone, and I'm going to try to sneak this in here, that's the 42 degrees right in there. Hope everyone's okay with that. So 42 degrees, and then that's the trajectory we used for 25 miles. So I'm going to put a big 25 on that. Now, again, just based on the way this works, we stop. So I'm going to draw myself another north-south line. If you could do the same, that would be great. And as it says, we're going to turn conveniently clockwise, so it looks like we're going to head down here. But it says 18 miles on a bearing of 48 degrees east of south. Okay, so here I am, everybody. And then here's my south axis. I'm going to rotate 48 degrees east of south. So we're going this way. And I'm going to now follow that bearing for 18 miles. And I'm going to try to keep this somewhat scaled. And so that would be this right in here. There's your 48 degrees. Sorry, I can't read that very well, but that's 48 degrees right in there. And then here I am. What I'm looking for, of course, is the distance. We're going to get that momentarily. And then it says, what is the bearing from the harbor to the position right here? So what is the bearing of the boat from the harbor entrance? So that's the key. As a matter of fact, underline that piece for me. That's what we're going to take a look at. So what is the bearing from the harbor entrance? Now, I had mentioned that this is actually a right triangle. We should actually show that that is the case here. So take a look at the numbers and the way I drew this for just a second. And I see the 48 degrees right in here. I hope everyone's okay with that. From the south axis to here was 48 degrees. If you kind of look at this geometrically, everyone, if this is 42 degrees right here, I'm not sure if you all remember the idea of alternate interior angles, but if that's 42 degrees, then that happens to be 42 degrees right in there. And if this is 42 on this part, and that's 48 on that part, 42 and 48 make 90. And so see if you could tuck that in there. It's tough for me to do this on the board, but essentially that's a right angle right in there. And it's only because these two numbers, of course, add to 90 degrees. This is then 42 and 48. So now, again, we can see, hopefully at this stage, that it is a right triangle, and then we can go ahead and solve appropriately. So let's do distance first. That's definitely the easiest. And certainly, guys, it's a right triangle here where I have two sides and need the third. We'll be doing this a few times over the course of the semester, but I'm hoping you all see Pythagorean theorem work out really nicely here. So 25 squared, 18 squared, and x squared right there. And if you don't mind, grab your calculator and go ahead and do a calculation for me. Just take this squared plus this squared, and then go ahead and square root that. And I did this already, so I have this one on my paper, but I get roughly, give or take there, about 30.8 miles. Okay, nice. All right, so the distance, really nice and straightforward, being that it is a right triangle. Now the secondary piece is obviously going to be a little harder here. Let's see if we can find a spot. So I want the bearing from here to here. And I'm hoping everybody is okay with the fact that it looks like we're going to rotate off the north axis all the way to this terminal side right here. So when I kind of talk about my bearing, and I'm just wondering how I'm going to tuck all this in, but I think I'm talking about the rotation from there to there. So I'm going to do this. If you can do this as well somehow in a better way, I probably should have made mine a little bigger. But essentially the bearing is going to be from here all the way to this terminal side. Well, I already have some information on this rotation, as you can see. I know part of the bearing, part of that rotation is going to be 42 degrees. The only thing that's missing, everybody, is this little piece right in here. And as a matter of fact, that looks like a nice looking acute angle. I'm going to call it theta. It's a nice acute angle theta in a right triangle. So I'm hoping everyone's okay, and we'll put this together first where we find theta. But it looks like the bearing is going to be the 42 degrees from here to here, plus the theta from there to there. Okay, let's find theta. So the key to these application problems that you are going to be doing is really interpreting what the bearing is in relation to theta. Here I see the bearing as the full rotation from here to here. We had 42 degrees. I need this little piece right in here. Okay, well let's kind of talk about this. It's right triangle trig, of course. Opposite, adjacent, hypotenuse. And here's my theta right here. It looks like we have the opposite side, and we do have the adjacent side. So I'm envisioning this, everybody, as the tangent of theta equals 18 over 25. And so what that should allow us to do now is an inverse on both sides here. Make sure you're in degree mode on your calculator, please. And so I'm going to do an inverse tangent on that 18 over 25. And when I do that, and again, you're more than welcome to please confirm this piece, I get an angle of about 35.8 degrees. So even though my drawing is not great by any stretch of the imagination here, I do see that this part of the rotation right here, that theta is 35.8 degrees. And so, and I'm going to have to come right up here, but let's be clear on how we're going to get the overall bearing. The bearing is the rotation from the north axis all the way to that terminal side, as I've mentioned, and it looks like it's going to be the 42 degrees plus my theta. Let's be clear on that. And so in this case, I'm getting my 42 degrees plus, what did we say there, about 35.8, and gets us around 77.8 degrees. Okay, which is great. That's the full rotation. Now let's be very clear on this piece. It's rotating off the north axis, everybody, so start with that. Now I include the numerical value of my rotation to that point, and we are going in an easterly direction. So I see that as the final result, along with that as the distance. So distance and bearing from one point to another. So I hope everybody sees that diagram all right. That is going to be a little tricky, so please don't hesitate, put a little question mark by it and ask questions. But I like that diagram, and I think that math works out perfectly. All right, let's get that last one. So example 4 here, I totally made this problem up, but let's see what it says. So apparently I went hiking in the Indian Peaks Wilderness and wanted to take the longer trail, not that there is one, to Lake Isabel. So I went 1.3 miles on that bearing there, then made a turn on a bearing of that for another 2.5 miles. So my wife and kids were at the trailhead and wanted to just go directly to it. How far were they from the lake? And what bearing would they take to go directly to the lake? Okay. Well, again, just very contrived, but whatever. It's a good problem. So here we go. Let's start out with the basics here. I'm going to try to maybe draw this a little bigger. Let's see. But start out, everyone, north-south axis right there. There's me. And I'm going to start going 1.3 miles on a bearing of 15 degrees east of south. So starting off the south axis, not too big of a rotation there, something like that for about 1.3 miles. So 1.3, and right in there, guys, I'm going to see if I can tuck that in. That's your 15 degrees. So east of south. Okay, good. So there's your 1.3. Now, I stopped. Trail takes a turn, and I end up going, let's see this. In this case, I'm going to go 75 degrees west of south. So here I am, of course. Here is the south axis, and I'm going to rotate 75 degrees, so quite a bit further west in this case, and go, what did it say, 2.5 miles? Again, try to keep it somewhat to scale. That would be my 2.5 right in there, and I'm going to put my 75 degrees right in there. Excellent. And here is the lake. Here is me smiling. Perfect. Now, here everyone is would be my wife and kids. They're going to walk directly to how far and on what bearing. Awesome. Good. Let's take a peek. So a couple things here. We'll get the distance momentarily. I had said that it's a right triangle, but let's show that that is the case. And take a look at this diagram, everyone, right around here, if you would. And first and foremost, you see along this north-south axis, and by the way, I hope everyone's okay with the full north-south axis there would be 180 degrees from here to here. So this I already labeled as 75. And take a look at the geometry, everybody. That's 15 degrees right in there. So alternate interior angles, if that's 15 degrees, right in here, guys, that's also 15 degrees. So 75 and 15 make 90, which means whatever's left, which is right in here. Let's see if I can draw that in. There's your right angle. Okay, good. So it is right triangle trigonometry here. Let's do the easy one first. I actually do not have these numbers, so I'll have to do it with you here, but essentially it's 1.3 squared and 2.5 squared equals the x squared. So I'm just going to go ahead and get an x value from my calculator here. So I'm going to bring it up, and let's see what we get. So 1.3 squared, and then I went 2.5 miles squared. Looks good. I'm going to square root this. And there we go. So looks like about 2.82 miles, give or take, from the trailhead. All right. Part one completed. So just the distance from one point to the other in a right triangle, absolutely perfect. Now here is where I would love for you to pause the video for a moment. So think about this for a sec, and then write conceptually, what do you think is going to happen here? I would argue the bearing that my wife and kids would take would be rotating off the south axis from here. This is it. Just from here to here, guys, would be considered the bearing. South axis in a westerly direction. What is that rotation right in there? So the question, of course, becomes how would you find it using the right triangle and using the information given? Okay. Well, here's what I came up with when I looked at this. I saw that my triangle is the rotation all the way from here to here. And in our triangle, I'm going to call that theta. So from there to there is theta. Hope everyone's okay with this. So that's theta. The bearing is just from here to here. And again, if it gets a little convoluted in my diagram, my apologies. But as I said, my bearing is just from there to there. So the way I'm seeing this play out, I'm hoping this will be the case for you as well, that my bearing is going to be equal to the full theta. So if you look at this whole rotation from here to here, the acute angle in that right triangle, whatever it may be, I'm thinking if we take away that 15 degrees, that would just be this part of the rotation right here, that would give me this. That would give me the bearing. So I'm seeing that as theta minus 15 degrees. And as I said, that's going to be your trick for these problems, is determining the relationship between the angle in the triangle and our definition of a bearing. Okay, well, we do have to get theta first, as you can see. So I'm going to just do it right here. And same scenario, guys. Look at it as a right triangle. Opposite, adjacent, hypotenuse. We have the opposite and adjacent. So let's see. As a matter of fact, I think I'm going to have to come here so my calculator can come up and I can see everything. But I'm thinking it is tangent of theta again equals 2.5 over 1.3. So theta is going to be the inverse tangent of exactly that. And let's see what that gives us. As I said, I don't have this just yet. Haven't quite worked this one out. So let's see. And so everyone, first of all, make sure I'm in degree mode. I'm sure you're in that already. So let me go inverse tangent and 2.5 divided by, and then 1.3. Looking good. So I get about 62.53 degrees. So theta, let me put that up here, 62.53 degrees. So again, that would be from here all the way to there as an acute angle. If I take away my 15 degrees, that should give me my rotation right in there. And so our bearing is going to be, what did we say, 62.53 minus the 15. And so I'm seeing this as just an angle measure. Let's get that rotation taken care of first, as about 47.53. Okay, not done yet. Don't box that up. So that would mean that from here to here, again, is a rotation of 47.53 degrees. Now we just have to include where we started, which was the south axis. There's the numerical value on the rotation, everybody. And I went in a westerly direction. And so that's it. That would be the bearing to take from the trailhead directly, apparently, to Lake Isabel. Okay, good. So please, everyone, take a look at some of those. Some good problems to set up. Half the battle is making a good diagram, and the other half is really figuring out this relationship here, as I said, between theta and the bearing. If you have any questions, of course, everyone, please don't hesitate to ask. And certainly good luck trying some of these problems out.